All right, so in today's video, we are going to be talking about a potential snowstorm threat that has showed up on some of the models for late next week and next weekend. A lot I want to show you guys, so I'm going to try to be as concise as possible, keep it as short as possible, just get right into it. But first, if you haven't yet, please hit that subscribe button. I would greatly appreciate that, help the channel grow. So let's get right into it. So this is the GFS. The GFS just raised some eyebrows on today's run. So again, the period that we're talking about is late next week and next weekend. So if we go to Thursday here, we have an initial storm that forms. This isn't the big one on the GFS, but Thursday we see low pressure start to form off the mid-Atlantic coast, bringing some snows to the Appalachians, interior northeast. Some rain to the big cities. That moves away early Friday. Cold air comes in its wake, and then we see another storm system start to form off the Carolinas. So we have snow, South Carolina, North Carolina, Georgia, even almost like northeast Florida here. So yeah, pretty unusual. And then it really starts to bomb it out, and you have high pressure, the classic banana high. You have high pressure to the west and to the north there in southeast Canada, and lots of moisture being thrown into that cold air. So you have very heavy snow along the east coast and then up into the big cities, the I-95 corridor. And this is now early Monday, and the system, you see, it's just sitting there, not really moving, so it's just dumping snowfall, especially along the Maryland up through New Jersey and New York City. I'll show you that in just a sec. And then finally, overnight Monday, early Tuesday, everything starts to wind down, but not before putting down a really historic snowfall amounts. I'll show you that right now. So this would be the biggest snowstorm ever, if this occurred as the GFS is depicting here. So, what's that, 3 to 5 feet of snow from Maryland up through Delaware, New Jersey, New York City. So it's reminiscent of Boxing Day. Actually, I mean, total's higher than that, but reminiscent of Boxing Day, especially where it's hitting and kind of how it forms synoptically. Keep in mind, now this is very far out, so this is 10 plus days out. So this is going to change. Do not think this is going to happen, but the models are showing there's a lot of potential. So, but wanted to show you guys that because that was really something. I'm not predicting 3 to 5 feet of snow. I want to make that clear. Just wanted to show you a solution that the models pointed out today, because we are entering a very favorable pattern, I think, that could produce a storm. So that was the GFS. Now let's take a look at the Canadian. You know what? Before we do that, I want to show you what synoptically what the GFS did to get to that solution here. So this is 500 millibars, and this is showing vorticity or energy in the atmosphere. So we're going to put this at next week, and we see this trough diving down into the southeast. That's storm number 1, and then we have a big ridge building on the west coast setting up for storm 2. So that moves out Friday, and then we have more energy digging down into the southeast. This is now Saturday. You see that trough really sharpening up, energy consolidating at the base, and then what happens is it cuts off from the flow there over the Carolinas. That's why you have snow down there, and Georgia, South Carolina, North Carolina, and then it just kind of sits there. It's cut off from the flow. You have ridging up over top of it with that high pressure, so it just sits there and throws that moisture into the cold air. So that's what the GFS did on today's run. Now let's pop over to the Canadian and see what the Canadian model did. So the Canadian digs upper level low into the deep south. This is now Friday. So basically now this would have been storm number 1 on the GFS, but the Canadian's handling it quite differently. It cuts off that first piece there. It builds the ridging out ahead of it and has a more substantial first storm, and doesn't actually have that second storm that the GFS did, and actually merges it with northern stream energy, and cuts it a little bit too far west for the big cities to get in on the snow, and merges with the northern stream just a little bit too late for a big I-95 snowstorm. But again, this is 200 hours out at this point. But it's a completely different solution. So again, multiple ways in this pattern here with that big ridge popping on the west coast, you have multiple ways to get a big storm. So we'll go to the surface of the Canadian and show you its surface depiction. So here we go. Now, midweek next week, storm system starts to gather in the deep south. You do have high pressure to the north and really starts to bomb it up. It moves it. There's just too late of an interaction with that northern stream to bring that cold air in, and moves it just a little bit too far west for the big cities. But look at that 975 millibar low. This is a big storm, very big storm. An earlier interaction, slightly different interaction, could bring the cold air in a little bit quicker and maybe shunt this thing a little bit further southeast to bring I-95 into it. So again, this is 200, 240 hours out, depending on, if we're looking at the Thursday, Friday time frame, or are we looking at later in the week or late weekend, that early following week. So models need to figure out what's going on with these pieces of energy before you can really fine tune the details. But that's a couple models. Now, the European AI is quite similar to the GFS, which is interesting. I think we have a couple different camps starting to form here. So this is the European AI. And here's that first wave that moves through, just like the GFS. So it doesn't bomb out that first short wave and cut it off from the flow that the Canadian did. It has it kind of moving, keeps it kind of a weak system there, just like the GFS, and then really builds that ridge out west, brings that next piece of energy down, cuts it off from the flow, just like the GFS, right? And that has that similar look to that Boxing Day snowstorm. So European AI looks very similar to the GFS, at least aloft. The surface depiction is a little bit different. But aloft is really what I'm going to be focusing on this far out. And that's similar to the GFS. And then, so a couple different camps forming here. So now let's pop over to the European model. And this is the last one we'll take a look at and see what the European is showing. So the European, let's put this ahead. So now there's that first piece of energy there diving down into the southwest. But unlike the Canadian, it drops it deeper into the southwest and really slows it up, so it doesn't actually have time to catch up to that northern stream energy right there. The northern stream energy, because it's slower in bringing out than the Canadian, that northern stream shortwave kind of compresses the flow, so you don't get those big height rises ahead of that upper level low. So it doesn't really bring it north as quickly. As you can see there, kind of slides it off the Carolina coast there, and this is now over the weekend. This is Saturday night. Slides it off, so it doesn't merge it with that northern stream, and because the flow is compressed there, it doesn't ride up and create such a big storm. But you have a weaker storm that stays further south, and because it is a little bit slower, that cold air is actually able to penetrate a little bit further south. So the Canadian, even though the European, a weaker storm than the Canadian, still has a nice little snowfall there for mid-Atlantic, northeast. You have 2 to 4, 3 to 5 inch type of event. DC, Baltimore, Philly, New York City, and then once you get up into southern New England, you have a 6 to 10 type of event from central Connecticut up through Boston. So a lot to be ironed out still with the models. They got to figure out how they want to handle these short waves. So we'll be monitoring that. It's going to be really interesting over the next couple days. Really interesting to see what the models start to do. If one camp, we really have a couple camps that are forming. Does one camp kind of move towards the other camp? Is they're going to meet in the middle? But that's what we're looking at now. Lots of scenarios, but a lot needs to be ironed out. So as more information comes in, I'll be putting out more videos, see what we're looking at there. But that's it for today. Thanks for watching. See you next time.